Welcome back, ladies and gentlemen. Let's allow the last participants to find an empty seat. It's a full house. Huh? The auditorium is beautifully filled. Before I run you through the afternoon program, I want to welcome some special unexpected guests. Because of the stormy weather conditions, our research vessel, the Simon Steven, could not sail today. And the captain and the crew decided to come here to listen what they are working for. These people service day in, day out to make this research vessel serve you as scientists to take samples and do your work at sea. So I want to give them a hand, a round of applause. And we are very happy that you are here and that I hope that you enjoy the afternoon. You're always welcome, but we know that usually you have other things to do when we have this day. For this afternoon, we will start with a short session with 5 pitch presentations at the postdoc level. There's also a vote afterwards, so you have a form to fill in that you can hand to the people at the door when you leave the room for coffee break. Then we will, after this, we will move to our second plenary presentation. And we are very happy to have Julien Barbière here from UNESCO IOC headquarters in Paris. The head of Marine Policy and Regional Implementation section will give us a presentation on the UN Decade of Ocean Science for Sustainable Development. Julien, very welcome, and thank you in advance for presenting later. This presentation will then be followed by an interactive Slido session that will be chaired by Tina Mertes. Shortly after that. Then we will break for coffee and a poster session, your last chance to visit the posters, to visit the demo booths and the likes. And during that poster session, after half an hour, I think, you should hand in your forms with your votes for the best poster. Okay? Then we reconvene here at 3:40 sharp. We will be joined then by the president of VLIS, the governor of West Flanders, who will attend the prize awarding ceremony. We have a lot of prizes to give, also preceded by very short 5-minute presentations by the laureates. The governor, Professor Karel de Kaluwe and Professor Colin Janssen, our vice presidents, will then formally hand over the prizes to the people that won them. But first, I give the floor to the postdocs, and we start with Jana Assel.
So, good afternoon, everyone. Here we are in Bredene at the seaside. And for centuries, oceans and seas have attracted millions of people, whether it is for recreation, for tourism, or even for the recovery after an illness. And as we've already seen this morning, this is because the oceans and seas make us feel healthier and happier. We often think it's because of the sea air. But what is so special about the sea or the sea air that makes us feel this way? First of all, let's have a closer look at our ocean. The ocean is a vast ecosystem containing many marine species, such as bacteria, algae, and jellyfish. And some of these species can produce what we call marine biogenics. These are biomolecules produced by these organisms. And as such, our ocean is not only a melting pot of many marine species, but also of many different biomolecules. And as you try to imagine these biomolecules, you can be very creative because they're very diverse. They can be vitamins, secondary metabolites, and even algal toxins. And what's so interesting about them is that they can become aerosolized through what we call sea spray aerosol. So this works as follows. Whenever these molecules are being produced, they end up in the ocean surface layer. And when waves break or bubbles burst, these molecules will become airborne and they will end up in what we call sea spray. And that sea spray is what we inhale when we walk or play or swim at the beach. And we wanted to focus on the sea spray aerosols because we think they might be one of the reasons why we feel healthier or happier at the seaside. And we wanted to know, what do these biomolecules do in the human body, and more specifically in our lung cells, as that's, of course, where they end up. We looked at the lowest cellular and molecular level using new sequencing technologies to make sure we could observe even the tiniest of changes. And the results were very interesting. What we saw is that these sea spray aerosols affect a number of different molecular pathways and genes, such as the mTOR pathway or PCSK9. Now I see you looking at me. I don't know these things. I have no clue what they're doing. But actually, you do know them. You do know them indirectly. And that is because these are involved in two of the most common diseases in the Western world. PCSK9, for example, is a major pharmaceutical target prescribed to patients which have a high cholesterol. And they get what we call a PCSK9 inhibitor as a last option after all other pharmaceuticals have stopped working for them. On the other hand, we have the mTOR pathway. Many anti-cancer therapies or drugs will target this pathway because interfering with mTOR means that you can stop the proliferation, or in other words, the growth of cancer cells. Now, am I saying that sea air can cure cancer? Should doctors prescribe sea therapy instead of radiation therapy? Of course not. That's a big too much of a leap, because I work with lung cells, and they're, of course, an extreme oversimplification of our lungs as organs and our human body in general. We need, of course, a lot more research to be able to make such a claim. But what I can tell you, or what we can conclude, is that biomolecules can play an important role into why we feel healthier at the seaside. They can also play an important role in the development of new pharmaceuticals. So what I want you to take home today is that we should protect our oceans, and particularly the biodiversity within, not only for the health of the ecosystems, but for our own health, because the oceans may well produce the medicines that we will need tomorrow. Thank you for your attention.
Hello, good afternoon, everybody. So, the Belgian part of the North Sea is an area which has a lot of human activities. And to understand the impact of those human activities on our marine ecosystem, monitoring is an important process. But what if we could actually increase the number of samples that we can analyze during our monitoring campaigns, and at the same time reduce the cost per sample? That would just be amazing. And that is exactly what DNA-based analyses are promising us. So at ILVO, what we decided to do is explore this possibility. And we sampled 4 diverse communities in the Belgian part of the North Sea with different levels of species diversity. And each of these 4 samples were identified with, morphologically by our expert taxonomists. After that, they were mixed in a blender. All these specimens were mixed in a blender, and of the soup we extracted the DNA. At the same time, we also extracted the DNA from the ethanol fixative of these 4 samples. And we tested 4 different primer sets for the barcoding region. And what we actually want to see is whether our morphology-based analysis and our DNA-based analysis are actually a little bit reflecting the same pattern. On top, you can see the number of species that were detected with morphology in each of our 4 samples. And we see that sample 120 here has the highest number of species, and ZVL had only 5 morphological species. Ideally, we'd like to have a similar number of species detected with our DNA-based analysis. And you can see here the results of the bulk fraction and the ethanol samples with each of the 4 primer sets. And what we see is actually the number of species that we detect is quite comparable. And also for the bulk samples, we see the same decreasing trend across our 4 samples. So that was really promising. But of course, it's not only about the number of species that we detect. We also want to see whether the species that we detect using morphology, whether they are also detected in our DNA-based analysis. What you can see here is the taxonomic composition of our sample. So on top, again, the morphological composition, and in the middle, the bulk composition of the bulk samples, and at the bottom, the composition of the ethanol samples. And I think it's clear from this graph that depending on the primer set that we are using, the taxonomic composition of our samples changes. And also there's a big difference between our bulk samples and our ethanol samples. And in fact, of the 59 species that were morphologically identified, 25 were not detected with our DNA-based methods. The good news was that 17 of these 25 species actually did not have a reference sequence present in our database. So no matter how hard we try at this moment, we will never pick those up because they are just not in our reference database. So we still have some work at this point to do. And this is exactly what we are aiming to do in the recently approved NTREC project, GENES, where we actually aim to increase the reference database with reference sequences from all organisms, all benthos organisms from the North Sea, and also want to harmonize the laboratory protocols between the different institutes of all the countries around the North Sea, because this is the way that we can actually increase our monitoring across the whole North Sea in an efficient way. Now, in the taxonomic plot, there was a lot of red, and the red indicates that we could not put a species name on that. And that means that we actually lose a lot of our sequence information. So what if we could actually use this information from what we currently are not knowing? How would that work? So I give you an example here. We have here areas, locations that have been highly impacted by aggregated dredging. And the dark green sites here are control sites. And we see with morphological analysis of the macrobenthos communities that the red and green samples are nicely separated. Actually, they are also separated if you look at the eDNA composition of the bacterial communities in these very same locations. Also here, when we compare the medium reference sites with their control sites, we see that they cluster together, which we also observe in our data. So basically, the bacterial communities are reflecting the macrobenthos communities, and this allows us to create a model. And in the future, we can actually sequence the eDNA samples and use the model to predict the ecological status of our sites. That is the future that we are aiming at, and this is actually one of the topics of the PhD of Laura van de Bolke. So I would like to end with saying that there is a future for environmental monitoring that is very bright, that is very exciting, and full of opportunities.
Good afternoon. My name is Olivier Gourgue from University of Antwerp. The interaction between plants and flow is really important to attenuate the flood propagation. In this very simple Lego experiment, we can see 6 little guys standing up, waiting for the storm. And during the storm, the big waves coming from the top, they are propagating inland. And as you can see, the propagation is more important in the area where there is no vegetation. So that at the end, only the 3 little guys protected by vegetation are still standing up. This is because vegetation increases the friction on the flow and therefore attenuate the flood propagation. This is something that is actually easy to simulate in this case because vegetation is very dense and quite homogeneously distributed. But in reality, it is much more complex. The coastal vegetation presents much more diverse fine-scale structures. And in general, large-scale models that are used to predict flood propagation, they are missing those fine-scale structures because they are too coarse. And in the next few slides, I'm going to show that it matters. So on the right, we have a simulation of flow through a vegetation box. The small black box, the big black box, represents more or less a grid cell on this figure. And within that black box, we have a random distribution of vegetation, the small white cells. So the flow is coming from the top, going through vegetation. It is attenuating through the vegetation and deviating on the side. On the left graph, I show you the discharge through the vegetation patch. And we consider for a given biomass within the black box, the big box, I show you different degree of clustering of vegetation. And what this graph shows is that the vegetation clustering, it decreases the flow attenuation. This is because for a given biomass, if the vegetation is clustered, the flow can find more easily a way through the vegetation patch. So now coming back to our large-scale model, we want to attribute a single friction value to the big black box, right? And usually models, what they do, they are using an approach where they account only for the average biomass, considering that the vegetation is perfectly spread over the box, the vegetation box. And this is a bad idea because, as you can see on this graph, the friction is overestimated and the flow attenuation is overestimated. Okay, so this is something we want to solve, and to do that, we are making an analogy to electronic circuit theory. On the left, you have the famous Ohm's law linking the electric potential to the electric current through the circuit resistance. And on the right, you have the Chesi formula linking the flow potential to flow velocity through the Chesi coefficient, which is a way to quantify the friction or the flow resistance. So now, if we consider all the small vegetation grid cells at the subgrid scale as a resistance, with high resistance for vegetation, low resistance for no vegetation, and if we connect those resistors in series along the flow and in parallel across the flow, then we end up with an electronic circuit like on this graph, which is very simple and very simple to determine the total resistance of the circuit, and similarly the total friction of our vegetation cell. So now if we apply this simple strategy, very cheap, to our case here, we can see that the discharge to the vegetation is much better represented. And that is, of course, a good idea, a good model. And now if we apply this method further to our large-scale models, we are now able to predict flood propagation in coastal areas more accurately. Thank you.
Hello, my name is Sven Sebastian Ullmann. I work as a fisheries biologist for the Institute for Agriculture, Fisheries and Food, ILVO. So my talk is about the Big Bang or the soft whistle, expected changes to the European fisheries as we know them under the landing obligation. The landing obligation is a new policy law that is being now fully implemented since the 1st of January 2019. And it obliges fishers to bring back ashore any of a given species catches of a quota or size regulated species. So this is a policy that has been implemented to actually stimulate more selective fishing, because it's inducing some costs to the fishers if they start to bring back unevaluable catches, for example, undersized species. So it's been really introduced to reduce that waste of living resources and to stop that practice of discarding, throwing back unwanted catches at sea. But any big policy change may have some undesired consequences, some side effects, next to the desired outcomes. So I've listed here some of those fears, if you want to call it like this, associated with the landing obligation. So one of the key desired outcomes would be that it actually contributes to management of fisheries stocks at MSY, so maximum sustainable yield, because essentially if you actually become more selective, you are reducing fishing mortality. But the fear was that it's actually not happening and that there's no recovery of the stocks happening. But healthier stocks would also contribute to more profitable fisheries. So the blue growth kind of phenomenon. But there has been a fear that because it does induce possibly some costs to fishers, that there's going to be an economic downturn for the sector. One of the desired outcomes was also to have more healthier ecosystems. But there's been a fear that because you're bringing back the biomass that was previously discarded at sea, actually ashore, that possibly some populations of scavengers, which may have relied on these food subsidies, may crash. And also that there's been a better and full documentation of what has actually been taken out of the system. But there's been a fear that there's poor data quality because if some illegal discarding still continues and we don't know about it. And finally, that this policy was meant to create a stewardship mentality, but the fear was that maybe fishers are really opposing this policy because it's been imposed onto them top-down. Just to summarize very quickly now some results from two Horizon 2020 projects, which basically wanted to evaluate whether there's any truth in some of these fears and also make sure that we can see some of those desired outcomes. So they really wanted to evaluate the impact of the landing obligation on the economy, ecosystems, fisheries management, and culture. So for the first one, and this is based on model predictions, in this case, stock assessment models. For the fish stocks, there's been some predictions that, yes, there will be a recovery, but only if fishers really fully comply to that policy. On the economic level, as I said, yes, there are some costs associated with this, and this is also showing up in the bioeconomic models that there is some decrease likely. For the ecosystems, there will be little disruptions to the food web. It's been predicted that possibly bird populations may suffer the most. And for the full documentation desired outcome, we can already see that there's very little reported of actually these unwanted catches because they would have to report this now since the 1st of January. So we possibly have poorer data at the moment. And for the stewardship mentality, yes, there's more discourse about the policy because of all this research that has been done and the management implication it has. But also because we are really shifting the attention from a landing to a catch regime in the fisheries management. We are really recording history at the moment, and we've combined efforts, and together with Clara Ulrich and Steve Kennelly, we've published a book recently which you can download from the website from Springer. So that's it.
Good afternoon, everyone. I'm very pleased to talk to you today about our research to find out how climate change will affect biological communities. And the communities we work with are composed of macrobenthos species, which are those invertebrates larger than 1 millimeter in size that live in and on the seafloor and can be highly abundant in coastal seas. And these organisms have a variety of traits which are often related to where they live exactly and how they feed. For example, this little mud snail here crawls over the seafloor grazing on benthic microalgae. Others, like this large clam, Scrobicularia plana, is not that mobile at all, but is extending its siphons into the water column to obtain food via suspension feeding. Others, like this ragworm, are more mobile, creating these gallery burrow systems in search for prey and therewith strongly ventilating the seafloor. And by doing all these activities, all these species interact with each other directly but also indirectly via their effects on their environments. If, for example, we take a typical sandflat community where those three species I just introduced you to make up the major part of the macrobenthic biomass, we know that the activity of the ragworm is making nutrients more available for microalgae to grow, but also that the same ragworm is consuming the microalgae. We also know that this large clam is actually reducing the effects of the ragworm via interference competition effects. And together with a lot of other interactions, this is how an ecosystem interaction network under ambient conditions looks like. So, and what we wanted to find out is how these community interactions might change along with ocean warming and acidification. So to do that, we brought these communities into the lab where we can experimentally mimic those warm and acid future conditions, and we looked into how the network structure was changing. And what we found was that under future ocean conditions, the network looks much more simple. It's much more simple, and in particular, the interactions in which the clam is involved disappear or change. And the clam is the clam is no longer affecting the ragworm, it's no longer depleting nutrients, and it rather stimulates microalgal growth. So, but why is that? And to find that out, we decided to look into the behavior of this clam specifically. And to do that, we used pressure sensors that we insert into the sediment and enable us to link specific changes in the pore water hydraulic to specific activities performed by that clam. And what we found is that that clam is actually shifting from suspension feeding towards deposit feeding with ocean acidification and warming. But why is this clam doing that? Well, we believe it's doing that because as it is deposit feeding, it's actually feeding in an environment which is less acid than the water column. And marine sediments have a higher buffering capacity towards pH change than the water column. In addition, as a deposit feeding event is shorter in time and occurs with a lower pressurization, it means that in the end the clam takes in less water. And it is exactly this lower pressure that is generated during deposit feeding that we believe is responsible for the removal of that competition effect with the ragworm. And this indirectly stimulates microalgal growth together with the nutritious biodeposits that are produced during deposit feeding. And this might be very well the reason why we found that herbivore species from different taxonomic groups might be more vulnerable, more tolerant to climate change and ocean acidification when the clam is present in comparison to the clam when the clam is absent. So what this means is that if we're going to lose large telenid bivalves, this might aggravate species vulnerability to climate change. And from a more general angle, it means that if we really want to understand and predict better how climate change is going to affect marine ecosystems, we definitely have to start considering non-lethal effects, such as behavioral plasticity, that can have cascading effects on ecosystem resilience, community interactions. With these two take-home messages, I would like to thank you for your attention. And if you're interested to use our experimental facilities, don't hesitate to contact us. Thank you.
A big thank you to all 5 postdoc speakers. Excellent presentations. Very diverse again. And the audience can vote now if they wish to do so. We now move to our session on the United Nations Decade of Ocean Science for Sustainable Development. I first give the floor to Julien Barbier, head of the Marine Policy and Regional Implementation section of IOC UNESCO, immediately followed by Tina Mertes for the interactive session. Julien, you have the floor.
Thank you very much, Jan. It's a real pleasure for me to be here in Ostend and to see such a vibrant marine science community. This is very impressive. You may not be completely aware about the IOC, so I will start by saying a few words about what we do. The IOC is not the International Olympic Committee, nothing to do with the Olympic Games. We deal with the ocean. So we are an intergovernmental oceanographic commission. We are sitting under UNESCO. We have 149 member states, and some of the representative of Belgium and the Flemish governments that attend the meetings of the IOC are here today. We are the voice of ocean science within the UN system, and this has been the case for the last 60 years. We focus in promoting ocean science, in developing ocean observations, facilitating the exchange of data amongst nations, and also building capacity all around the world. So today, and of course, I also want to highlight that IOC and the Flemish marine scientific community has a long history of collaboration. We've been, some of you may be aware that, for example, here in Ostend, we have the International Ocean Data Exchange Project Office of the IOC, which is basically the data management arm of the IOC, hosted by the Liz and we had more than probably 2 decades of very good collaboration with the Flemish community. But today I'm here to speak about the plans for the UN Decade of Ocean Science for Sustainable Development, which will actually start in 2021 until 2030. And to update you, inform you about how we are planning to develop this decade and how you may want to contribute to this, because this is not just a UN decade, this is everybody's decade. It belongs to the marine scientific community, it belongs to citizens, it belongs to policymakers, and we'll discuss this maybe in more details. But before we get to the decade itself, let's set up the landscape a little bit. Of course, I think we can all revel in the fact that ocean issues have really risen in the last 5 to 10 years on the political agenda. And one of the reasons for that is a number of international agreements that are related to the ocean. Of course, we now have the SDGs, and of course, I've seen all of you have a SDG badge there, and that's very good. And in 2015, nations around the world committed to achieve a number of ocean sustainability targets as they are embedded in the SDG 14. We also have now a very important negotiation in the UN for protecting marine biodiversity in the high seas under the Convention on the Law of the Sea. The climate discussions are now also looking at the ocean and trying to understand how climate and oceans interact and what are the impacts of increased CO2, what kind of mitigation and adaptation strategies are needed for the ocean. We also have the disaster risk reduction community, who's also has been impacted in many years by ocean hazards, tsunamis, storm surges, cyclones have been very high on the news. So I think there are a number of political kind of engagement and commitments from member states, and that's all very good. We also have a growing awareness amongst citizens and amongst stakeholders. For the first time, we had a UN Ocean Conference in 2017, and there will be another one next year in Portugal. We have a plethora of international meetings on the ocean. We have every year now our Ocean Conference, this time in Norway. In November, the Kenya hosted the Blue Economy Conference. We have a World Economic Forum trying to bring the private sector and business operators also focusing on ocean sustainability. The G7, the G20 are trying to look at how they can promote better ocean sustainability. So this is pretty good. I think we are in a good spot. But is this really making a change? What is the reality check on the ground? Just if we look at a few important parameters which we know are impacting the health of our oceans, carbon emissions are still growing pretty much, at a very high rate, much higher than what was committed at the Paris Agreement. And this, of course, puts us on a course which is well beyond the 2 degrees of increase by 2100. And that, of course, will have major impact on the ocean. Ocean acidification is one clear aspect, but also the degradation of very important ecosystem services that the ocean provides to society. At the same time, I think we can also say that the ocean, and particularly ocean science, is still pretty much underinvested. This is just a graph that shows you not so much maybe on ocean science, but more generally how the SDGs are being funded by philanthropic organizations. You can see here that our Oceans SDG 14 is one of the lowest degree of investment there from those donor organizations. So clearly this is not enough. We also know that, in terms of ocean observation, we know the ocean is expected to deliver more than $3 billion US dollars in terms of 3 trillion in terms of benefits globally every year. At the same time, we only have about 1 billion which is being invested in ocean observations. And we at IOC are coordinating ocean observations, and we invest about $300,000 US dollars per year just to do the coordination. So clearly, there's a problem here. We are not looking at the investments and the infrastructure sufficiently. And but of course, this has impacts in several regions where there is even hardly any observations being undertaken. We also have, and that's probably, sorry, right, that's the one. We also have the issue that not everybody is equal when it comes to capacity to undertake science in the ocean. We still have many gaps in terms of capacity development. This graph comes from the Global Ocean Science Report, which was our first attempt in 2017 to come up with a picture of where countries are investing in terms of infrastructure, in terms of human capacity. And this provides an overview of the productivity in terms of the science papers which are being produced by the countries. And of course, we see Europe, we see North America, and of course some part of Southeast Asia, being quite voluminous. But if you look at Africa, if you look at Latin America, the Caribbean, Pacific Seas, small island developing states, we have major gaps here. So this is also something that we need to address if we really want all countries to have the capacity to achieve those sustainable development goals. So it is probably time maybe for a new social contract for natural science. And this is really where we start conceptualizing this UN decade. We know very much that ocean science remains a voluntary endeavor, while at the same time we have a number of legally binding treaties that requires this science and has to be embedded in those pieces of legislation in a more systematic way. So we know the ocean science is under-resourced, the governance is weak, the capacity is unevenly distributed. So we need to build oceanography that is fit for highlighting problems, but also for starting to systematically provide solutions. And we need to mainstream this ocean science in all of those aspects. So it is time for change. And this is why in 2016, the nations that formed the IOC started to discuss a global initiative to try to really strengthen this support of science towards the achievement of sustainable development. And at that time, we decided to engage all the IOC member states. And then we thought this is bigger than just the IOC. If you look at the SDG 14, SDG 14 has many ramifications for other SDGs as well, whether it comes to economy, employment, climate, fresh water, and so on. So we need to go in much bigger endeavor, and this is why we decided to go for this UN decade. And the first task that we had was to come up with a vision of a decade, and you can see here the vision statement, which is to develop scientific knowledge, to build infrastructure, and foster partnerships for a sustainable and healthy ocean. And of course, we went to the IOC governing bodies, then we went to the UN General Assembly. And in fact, it didn't take long for getting the support that we were hoping for. Many countries realized the importance to have such an initiative to really help and back up the implementation of the Agenda 2030 and the SDGs. But what is also very important is when we decided and we thought about this decade, we felt that it cannot be business as usual. It's not just packaging things and making it nice and making it, telling the nice story and how policy relevant. It's really to define a transformative nature of everything we are doing. And there are different elements there. It's really about radically changing our understanding on how the ocean contributes to sustainable development. It's really about translating research outputs into issue-driven solutions. It's stimulating the integration of social and natural science, which is not done enough, but also traditional knowledge. We need to look at the traditional knowledge. It's strengthening the uptake of science by policymakers and citizens. It's promoting partnership with the private sector. We know the private sector is becoming a major actor in research and development, and we need to work out some good models of collaboration. We also know that new technologies are emerging, and we are really on the curves of a new dawn, and we need to harness these new technologies to better understand, observe, and deliver information on the state of our ocean. So it is also about really enabling access to open data and information to all people and all stakeholders that need it. We need to also bring in the early career scientists. So I'm very happy to see very many early career scientists, and I hope you can all embrace this decade and use it in your work. But also we want to stimulate gender mainstreaming. We want to address the needs of small island developing states and least developing countries. And finally, this is also about bringing the different parts of the UN together in this endeavor. So we need principles to do that. It's not just a nice statement, but it's important that this translates in the way we are developing this decade. And one of the approach we have taken is that instead of starting with a number of scientific priority areas that I'm sure the scientific community will be very excited to promote and to define, we need to look at what it is we're trying to achieve and really look at the societal outcomes we want to get to in 10 years from now. So we've decided to frame this really around this a number of, in fact, six societal outcomes, which are all related to the SDGs, to international commitments. So it's nothing really new there, but it's really how we're going to get there through scientific research and better dissemination of information and data. So we're looking at the clean ocean, and here we're thinking, how can we really build the science to really identify the sources of pollution, to quantify them, to reduce them, come up with new technologies? It's a healthy and resilient ocean, really trying to understand how marine ecosystems are providing services to humanity. So to start that, we need to have a better map of the seafloor, for example. This is we only have about 6 or 7%, which has been mapped in high resolution. That's not sufficient to support sustainable development, to support management. So we also need to understand cumulative stresses and their impacts on the marine environment. We need to build a predicted ocean, where society has the capacity to understand current and future ocean conditions, to forecast their change and impact on human well-being and livelihoods. We want a safer ocean, where human communities are protected from ocean hazards, and where operations at sea are conducted in a safer environment with better information. We want a sustainable, productive ocean, and it's really looking at the way the ocean is providing food supply and what kind of sustainable livelihoods can be secured from there. And finally, it's really about getting a transparent and accessible ocean, where by this we mean that where countries, where stakeholders have better access to information, where the ocean becomes something which is really visible, not just this blind area on the map. And that, of course, requires technical skills, capacity development, education, and engagement with citizens. So in order to get to those societal outcomes, we need to achieve a number of scientific breakthroughs, and those include the mapping, the observations, and those will then somehow be delivered in a very applied manner so that they can support the efforts of countries in implementing coastal zone management strategies, marine spatial planning, blue economy, aquaculture and fishery management, adaptation to climate change. So those are very concrete societal applications. And that's really I think the central philosophy of this decade. It's not just science for science, it's science for applications of sustainable development. And to do that, we need to work on those research and development priority areas, and this is really what we are starting to do now. I mentioned the map. Of course, we want the seafloor to be mapped, but more than the seafloor, we need to understand what kind of ecosystems are there. We need to look at the geology. We need to look at how the observation systems are being operated. We know that currently, with the floating buoy, the Argo program, we can measure up to 2,000 meter depth. But most of the high seas are much deeper depth. So, and we now have human activities in those regions. So we need to develop ways to be able to monitor those areas. We need to conduct an inventory of ecosystems and their functioning. So I saw earlier mention of eDNA. That's very important. We have developed the Ocean Biogeographic Information System, OBIS, which is hosted by IOC. But we need to take all this to another level to be able to really support policy. We need to invest in data and information sharing and dissemination. And of course, this is something that requires infrastructure and capacity development. We need to establish integrated multi-hazards warning systems. We need to develop Earth system models, which really also integrate the socio-economic dimensions. And we need capacities to accelerate technology transfer and ocean literacy. So those are some of the kind of core, package areas that this decade is going to look at, and of course get the community to plan and strategize on further developing those areas. But I think the decade also provides maybe a renewed cooperation framework for ocean science. It's really about mobilizing scientists on critical ocean priority areas relevant to the sustainable agenda. It's about bringing together researchers to synthesize research and defining trends and knowledge gaps and priorities for future research. It's about developing co-design research strategies, for example, with social scientists, but also with the users. It's about fostering new joint research and cooperation within and across ocean basins. So, the ocean is an international forum in itself. It's about synthesizing, assessing results, and making sure that those are fed into policy and societal level through various mechanisms. And of course, all of this requires stakeholder engagement from the start. Don't have to engage stakeholders at the end only. It requires funding and partnership. So it's really looking at how we can align investments in ocean science around the world. It requires integration between natural and social science, and it requires capacity development. So this engagement phase is very important. So what we are doing now in the next year and a half is actually critical. We've been tasked to deliver an implementation plan by 2020, which is really inclusive, that really reflects the contribution of different stakeholders. And what are those stakeholders? Those are, of course, we need to start with the ocean science, I would say the technology community, because this is you. And you're here to help us to formulate priorities, to advance and align the agendas for global ocean science, and to increase this uptake. It's, of course, the policymakers, the ones who are going to fund the research, who are going to invest, who are also going to highlight the needs for specific solutions and the sustainability challenges that governments and local authorities are facing. It's also the business and industry. We want them to access and to help us develop solutions. They are, as I said earlier, they are investing a lot in research and development. They are holding a lot of data on the marine environment that also could really help research. So it's really about getting them involved in developing public-private research models that can really help. Civil society needs to be, of course, in the pictures because they give evidence base and they can prioritize advice and can be the voice of civil society. We want donors and foundations because we want them, of course, all of this will be resource intensive, and I guess what we are trying to do is really boost the investment. So this requires alignment as well as leverage of investment in order to have high impact in global ocean research. And of course, we need the public involved because the public will be a really important end user of this, hopefully leading to increased awareness and triggering behavioral changes on the way they see the ocean. So to do this in the next couple of years, we have a process in place. IOC, as I mentioned, is the lead is coordinating the preparation of this decade. We have established an executive planning group, which has it's about a group of 20 eminent scientists, but not just ocean scientists. We also have social scientists, we have lawyers, we have people with more focus on legal aspects. We also have a series of regional and global meetings that we are planning in 2019 and 2020. And those are really multi-stakeholder by nature. So we won't really have use those meetings as a dialogue across between the science community, between the private sector, the policymakers, and civil society. And of course, this is at the global level, but at the national level, countries should really also take ownership of this decade. This is not just a UN decade, as I said earlier. This belongs to all of us. So I would really encourage you as a community, as a Flemish science community, to use this decade to start the dialogue with your governments, with the economic sectors, with civil society, to try to see what you want to get out of this by 2030. So we have several meetings coming up, and the idea, one of those first meetings will be actually in a couple of months from now in Copenhagen. This is the first global planning meeting, and will help us to really flesh out a little bit more those research and development priority areas that I've mentioned, but also address a number of cross-cutting issues such as capacity development, financing, communication, data sharing. And then the idea is really to take the decade to the regions, to the ocean regions. So we are foreseeing a series of about 8 to 9 workshops in all major ocean basins. The first one will start in the South Pacific region in July, and then we will have another one same month in the North Pacific, and so on. And so we are in the course of defining those venues, getting host countries and organizations engaged who want to contribute. And there, basically, these meetings will help us to really first communicate what we are trying to do, but understand what are the regional priorities in terms of research, in terms of capacity development, in terms of data information gaps, and trigger the development of transformative initiatives under the decade. And all of this will bring this back at the beginning of 2020 through another global planning meeting, which will have a task to basically consolidate, synthesize all those regional inputs, and integrate them into the planning process of the decade, which will be brought back to the UN towards the end of 2020. But of course, as we are moving forward, we need to look at the partnership elements, the financing elements, and this is something that we are working very hard on. I'll skip that one. So this is just the timeline that we have in front of us. It's very intensive. We have a number of meetings being taking place, and we hope that by 2021 we will be ready with the start of this decade. And we already are foreseeing a big major event somewhere in Europe. I can't say too much about this, but this will be the kickoff, the official kickoff of a decade. And of course, what is important is that we engage a number of regional and global players when it comes to the ocean, and we are very much doing this, working with regional partners, with other UN bodies, in order to help and to build this partnership element, which is so important. So, in conclusion, I think meeting the societal demands in achieving the SDG 14 can really only be realized if all the elements of the ocean value chain are resourced and adequately, and the science agendas are advanced. And of course, to do this, we need global capacity development and resource sharing between nations. We also need to deliver data and information for integrated research, which can support policy action, which can support public and private sectors. And we need to build on new technology, which needs to be shared, and we need to harness the digital revolution to deliver the information where it's most needed. And to do that, we need the help of everybody, so we need your help. So please take ownership of this decade and use it. And so, in conclusion, I just want to, again, thank you. I just want to highlight some of our partners who are contributing, providing in-kind support, but as well as financial support. Government of Norway, the Japanese government, the Korean government, the Flemish government, which was one of the first to actually provide some support to IOC. The Pacific community, the European Commission also, we are working very closely to try to align our agendas and really to find convergence with DG Research and DG Marine, for example. So with this, I want to thank you very much. And again, this is your decade, so make the best of it. Thank you.
Okay, since there is a problem with the presentation that was sent, we'll see if we can get it. Yes, there it is. Thank you, Peter. So before we go and interact a little bit more, like this morning we did with the Slido, I will put it on. I will first want to give you some first results of a survey we did with some of his colleagues as for the Belgian contribution towards the UN decade. So as Julian already mentioned, we want to look at the ocean we need for the future we want. And the workflow we tackled was the following. Starting from December, we had some interactions with different scientists at different fora to see what the contribution of Belgium could be towards the UN decade. We first started in December during our open scientific committee with a brainstorming session. Secondly, we put up an online survey, which we then complemented with in-depth interviews with some 20 privileged witnesses, some senior scientists, but also young wolves, like we like to call them. Some of you are present here. And we need your input today. So that's for some minutes later. And by the end of this month, we will hand over a synthesis report to our governmental officials. So in December, we questioned the audience with 4 questions. At the end of the question, you always see how many people reacted or how many responses we had. We first started to question what the societal relevance of your own research could be towards the UN decade. And we had different answers, clustering, coming from relevance towards more economical assets, sustainable future, contributing to a sustainable future, safety, communication, health, well-being. So you can already see that it's quite diverse, which is very good, what the subjects that our scientists are tackling. The second question was, do you see where is the need for more capacity building? So where do we need to have more training from, for instance, at educational level? And there were a very variety of answers going from ecosystem services towards science communication, marine spatial planning, citizen science, marine robotics, etc. So all these answers are more or less clustered in this word cloud. The third question was, do you see opportunities during this decade? What can mean the decade for you as for financing, visibility, cooperation, etc.? And we had a very diverse input, not only focusing on those 3 topics, but also on, for instance, transdisciplinarity, monitoring, open data, public engagement, land-sea interaction, etc. And the last question we ask is, where do you see yourself or your research linked to with the current SDGs? So here you have already seen it a lot today. And unfortunately, we had like 4 SDGs that were not answered, but all the rest were tackled by the audience present that day. So next, we put up this online survey. We asked 18 questions to several scientists, and they are more or less bundled in 3 topics. So first, we looked at the awareness and knowledge on the SDGs and UN decade. Then to the contribution they were thought they could contribute to the UN decade, and also the opportunities. So these are some first results because we're still doing some interviews. As for the awareness, we were quite happy that a lot of them already heard about the SDGs, more than 90%. The UN decade a little bit less, and then the roadmap, like Julian presented, was less known. As towards their contribution, you already heard about the different societal outcomes that the UN decade is tackling. The main societal outcomes that the researchers thought they could contribute to were on healthy and resilient oceans and a predicted ocean, and the least were on a safe ocean. Of course, that is consistent with the people we interviewed, but this is more or less a general outcome. As for the contributions towards the strategic objectives, you see the objectives listed on the right-hand side. Most of the answers went to, well, we will contribute to generating more knowledge about the seas and our ocean, and also enhance the observation networks, data systems, and other infrastructure. And the least was objective 3, save lives and reduce risk. So that's linked to the previous one. As for opportunities, we were happy to see that the scientists believe that the UN Decade will create more visibility on an international level for their research, but also extra funding opportunities. So you can see the purple and the blue graph on the left-hand side, which are strongly agreed, and then agreed and strongly agreed. It's around 60% for funding opportunities. As for opportunities on capacity building, we asked for 7 different capacity buildings topics. I will question them later to you as well. And we saw that it's quite scattered, but most people thought it should be good to have more capacity building towards data and information management. That's the more than 90% of our correspondents answered that. And as for the rest, everything is more or less very important to improve in the future. But now it's up to you. So please, can I ask you again to take your mobile phone? The ones that people that were not here this morning, please go to slido.com and you will have a code that you have to enter. It's 4160. And we already had this question this morning. What is your age? But the next question we want to ask is, please be honest. Have you ever asked? Well, have you heard already about the SDGs before you came to this event? So we're with around 350 people. So you see the counter on the top right-hand side. I hope we can reach at least 300 answers. So till now, a lot of people said they heard about the SDGs. That's quite positive. But I will give you some extra time. Because for us it's very important to get this input today. We will also use it in the report we are going to write. So the more input we get, the better, of course, it's balanced. So once we reached the 300, I hope we will reach 300 answers, then we can go to the next question. It's more or less clear. I think it's around stable. 70% was familiar before today with the SDGs. That's very positive. So I will go to the next question. And do you think the UN Decade is relevant for your future research? Given all the talks you heard today, the talk about from Julian, do you think it will be relevant for your future research? So I can repeat that it's anonymous what you will answer or who is answering which question, and you can only vote once, of course. So I think it's very optimistic. Well, I hope it stays on the yes stays on the higher side. So we can clearly see that people are hopeful. That's good. Here the audience is very hopeful on what the decade can mean for you. Okay, so we'll go to the third question. Here you can normally click on different answers, so click more than one. So there are different domains for capacity building where we want to focus on in the future. And the fact we want to ask you where you were trained in during your education. So were you trained to tackle a multidisciplinary approach? Were you trained in applying ecosystem-based approach in your research? Were you trained in managing data and information? Were you trained in policy instruments and science policy interface, etc.? So I will give you a few, 2 minutes or something, to see which is the lowest on the bottom. That's mainly because is maybe the topic we have to tackle more in the future, where there is not a lot of capacity building now in educational programs. So please vote for different subjects. So now it's between multidisciplinary approach and ecosystem-based approach, which is tackled the most in education. We will see whether it changes. So until now, the least training is towards infrastructure management. It stays more or less the same. Okay. More or less everybody voted. Well, not all of you, but still a lot of contribution. Thank you. So I will skip to the next question. And then normally you can also vote several answers. Thank you. Are you willing to, first, deposit your data in open access databases? Second, frequently, let's say 6 times a year, inform a wider audience about your research. And third, are you willing to inform policymakers about your research? So please vote for different, and just be honest as well. If you're, say 6 times is too much for me, then maybe you should not vote for that topic. We're very happy to see at least that a lot of people want to share their data, which is very good. You know that VLIS has a marine data archive, so you can freely use that to deposit your data, but there are, of course, other databases as well. I think we more or less reached the number of people that were participating already. And then my final question is, we want to make a word cloud. So can you please send us one word? Normally you can just enter a word, what the UN decade can mean for you. So, and the more one word, for instance, future, the more it is sent in, then we will have a very nice word cloud. So jellyfish, money, okay, hope. Funding is voted a lot. And Jonas is also very important, apparently. So thank you for your contribution and have a nice afternoon.
Thank you, Tina, for sharing this interactive part. Thank you all for participating. Thank you again, Julian, for sharing this latest news, these latest developments about this UN decade for ocean science. It's something really important for us that is happening. I think it's very clear that we will have to engage as a science community with this process, but also with other target groups, that we have to align efforts, that we have to reflect together with all our disciplines and our expertise how we can contribute to make this decade a success. And as VLIS, we will try to come back to this decade regularly in years to come. We now have a break, but it's really a poster and demo session. So it's your last time to check out the posters and vote for your best poster. With respect for the governor's time, we should be in the auditorium at 3:40 sharp, so that we can start immediately with the last session. Thank you very much.